In this video, I explain an example of a problem involving the computation of the present value of a general annuity. The problem says, an installment contract for the purchase of a car requires payment of 252.17 at the end of each month for the next 3 years. Suppose interest is 8.4 per year, compounded semi-annually. What is the amount financed? So if we see this problem in time, so we're gonna see that in 3 years we are going to be paying every month 252.17. So it looks like this. And because what we want to compute is the amount financed, so the amount financed is always at the beginning of the annuity. So with this 252.70, we are paying this amount that is owed at the beginning. So this is actually the present value. Anytime that we have a loan, a mortgage, or something that we owe from the beginning and we are repaying with periodic payment, or we need to compute the present value. So this amount owed at the beginning is always the present value. So what we have, we know that the formula of the present value is this. Present value in end payment equal R, the payment, the periodic payment, multiplied by 1 minus 1 plus I to the power negative n, everything divided by I. So this is the formula for computing this present value. And what we have, we know that the payments are 252.17. So this is something that we know, and this is something that we need to put in the formula. Another thing that we need to put is the n, the number of payments, how many payments. And it's easy to find if we know k, because we know that we are making this payment every month. So we know that k, the number of payments per year, are 12. So after we know this, we can compute the number n. N is actually the total number of payments. There are 3 years, 3 times 12 is 36 payments. So n equal the time in years, time the number of payments per years. So the 3 times 12 equals 36. So now we know what is n, and the only that is missing is the periodic rate of interest. But this periodic rate of interest needs to be monthly. However, what we have here is the interest compounded semi-annually. So we know that the nominal rate of interest, so the interest is 8.4% per year. So it will be R, nominal rate of interest, 8.4%. And this is compounded semi-annually. This is every year we have this interest, but this interest is computed 2 times per year. So M equal 2. So we know that K and M, the number of payment per years and the number of conversion periods per year is different. So this is a general annuity. And it's ordinary because the payments are at the end of every period. You can read here at the end of each month. So M equal 2, K equal 12. These two numbers are different. This is a general annuity. Then use the formula to compute for computing I, the periodic rate of interest, compounded the number of payment per years. So this is I, the I that we need to put here in the formula. Is 1 plus R over M to the power M over K minus 1. M is the number of conversion period per years. K is the number of payment per years. R is the nominal rate of interest. Okay, so make a substitution of everything in the formula. This 8.4% is this 0.084. This M is 2. K is 12. And this M appears again here in the exponent, at the numerator of the exponent, M. So use your calculator, and I use my calculator, and I compute this, and the answer was 0.0068805553. So the first thing to do is compute this periodic rate of interest. Compounded the number of times per year as is given by the number of payments. And then, after you have this I, substitute this I in the formula. So when you are solving the problem of present value of an ordinary general annuity, the first thing to do is computing the periodic rate of interest and using this formula always. So I did that in the calculator, and I put this number in the memory of the calculator. So I used the sharp 520 for doing that. So this was my calculator. I compute the value 0.0068805553, and I store this in the memory of the calculator, or in one memory of the calculator. Let's see. So what I do to store it, I click store, and then choose whatever of this memory we have here, A, B, C. Everything that is written in green here is actually a memory. All the things, the letters that are written here in green are actually memory of the calculator. So let's store it in the memory A. Store, when you press store, you see this alpha appears here at the top in the screen. And you can see the key that I press on the left side of the screen. And then, because I'm going to store it in the memory A, I'm going to press this, store A. You can see in the screen that appears answer to the memory A. So now I know, even if I delete the screen, or I clear the screen of my calculator, this number will be in the memory of the calculator. So now I can substitute everything in the formula. Let's substitute everything in the formula. That is what I'm going to do. So I'm going to type 252.17 instead of R. Instead of this I will be this number that we already computed, and N will be 36. Okay, so let's do it in the calculator. So type 252.17, and you see the number in the screen. Because I tap the number, appears that everything that I tap in here is also appearing on the left side of the calculator. Okay, 252.17, there is a bracket, so I'm going to open bracket. This is opening the bracket appears in the screen of the calculator. And 1, so I type number 1, minus, and there is another bracket, so I'm going to opening the other bracket. So I'm going to open the bracket, so it will be open bracket, and 1 plus. Now that I need to type this number that is too long, I prefer to write recall A. So this key recall for recalling the memory. When you press recall, appears the alpha again in the screen. Recall, and then the memory that I'm going to recall is recall the memory A. So again appears the memory. In the formula that is written also in the screen appears A, the memory I'm using. So I'm going to cross the bracket, this bracket that you see here in the screen. You are going to cross the bracket, and then to the power, this is the key power in my calculator, y to the power x. So I'm going to the power. In the screen appears this symbol, and to the power negative 36. So this is the negative sign that you need to use for the negative number. Press negative and then 36. So negative 36, and this negative 36. After doing that, and then there is a closing bracket here. So close the bracket, and this appears in the screen of your calculator. Divided by, again, the number that is in the memory of your calculator. So divided by recall A, and then you can press equal. So you press equal, and that gives you the answer in the calculator, 8,016.87 if you round it to 2 decimals. So it will be the number. This is the amount financed, and that's it. This every time that you need to compute the initial loan, the initial debt, you need to compute the present value. And anytime that you have noticed that the number of payments are different than the number of conversion periods, you need to compute I in this way. With this, I finished my explanation of this problem. Thank you.